Okay, so 10.2 is on logarithms and logarithmic functions. So it says, suppose you want to know how many times you have to multiply 2 by itself to get 8,192. Okay, you could do that on your calculator. You could just keep doing 2 times 2 times 2 until you get the answer. Or you can actually use something called logarithms. Okay, so a logarithm, it's defined to be the exponent to which a specific base is raised to obtain a given value. So logarithms are exponents. They don't really look like exponents when we use them, though, so it's kind of confusing for people. But all right, so an exponential equation looks like b to the x equals y. Okay, if I want to change that to a logarithmic equation, so exponential is what we did before. So let's say I wanted to solve for x. You would do log base b of y equals x. Okay. So here's what I always think. So I'm not going to walk to the front of the room. But I always think, okay, the log of the exponent is the same as the log of, or the base of the exponent is the same as the base of the logarithm. So see how it's base b and base b? All right, then I think, okay, b, I skip over the equal sign, so b raised to the x equals y. That's how I get it back in the exponential form. Do you guys see? So I always do that circle. I do b to the x equals y. What's left? Okay, so when I start here, I have a, so circle that, a to the y equals x. So that would be its exponential form, a to the y equals x. Can you guys go backwards? So at number 2, if I have 2 to the third equals x, it's going to be log base what? 2, because base of the logarithm is the same as the base of the exponent. What do I put next to the 2? X equals 3. See, 2 to the 3 equals x. You guys get it? You have to know that, otherwise your test will be a disaster. All right, so how about this one? A to the a to the x. What's left? Yep. So a to the y equals a to the x. All right, number 4. Log base 4 of x equals -2. Okay. Another thing that drives me crazy about logarithms is some people think that it's written like this. Log of 4 to the x equals -2. That's not how I'm writing it. This little number is a subscript. It's tiny. It's like the opposite of an exponent. So you guys aren't writing it like this, are you? So don't write it that way. All right, so number 5. So let's learn how to solve. So if I have log base 10 of x equals 3, this is no longer going to be scary to you when you see it, because right now you're probably freaking out. You're like, I don't know what a logarithm is. All right, switch to exponential. So 10 to the 3 equals x. Well, what's 10 to the 3?
30.
Not 30. Not 10 times 3. 10 to the 3, so 10 times 10 would be 100, so times another is 1,000. So 1,000. It has 3 zeros. That's how you can remember. All right, how about this one? So switch to exponential. 16 to the half equals x. What is 16 to the half? 4. It's the square root of 16. So it's 4. All right, common logarithm. So this is a logarithm with base 10. If no base is written for a logarithm, we assume it's 10. This is called the common log. Okay, this is what's on your calculator. So when you guys see the log button on your calculator, did you guys see that? That's log base 10. So if there's no base that's written there, it's base 10. So when I see log of 1, it's log base 10 of 1. Now I hear you guys clicking away on your calculator figuring it out. All these we're going to do with mental math. Okay, so imagine that this was equal to x. You don't have to write this, well, you might want to write the x so you can see it. So you have 10 to the x equals 1. So what's x?
1 over 10.
0. I heard someone say it. I mean, you're still thinking multiplication as well. Raised 2, raised 2. All right. So this is log base 10 of 10,000 equals something, so equals x. So I have 10 to the x equals 10,000. So what is x? 4. Count the zeros. That's the number of times 10 has been multiplied by itself. So 4. So I have 10 to the x equals 1,000. I heard someone saying, it's 3. It is 3. You're right. 3 is right. Okay, this next one. This is no longer 10. Okay, so I have 5 to some power equals 3125. So let's say we were stuck and we didn't have a calculator. Yeah, you can keep dividing by 5, divide by 5, divide by 5. Or you can think, do you have a guess? It would be multiplied by 625. All right, so if I have 5 to the first, that's 5. 5 squared is 25. What's 5 cubed?
225.
Close. Think of 5 quarters, right? 5 or 125. 5 to the fourth. Anybody know that one?
600.
625. So what do you guys think 5 to the fifth is? 3,125, right? So x is 5. So if you need to write those off to the side, you can. Okay, next one.
Did you just erase?
Yeah, I erased it. I know. That's it. You can write them if you need to. But. All right, 15 to the 0 equals 1, right? That's how I got that. So let me write the x. I did it in my head as you guys were talking. So it's 15 to the x equals 1. So anything to the 0 power is what's equal to 1, so it's x equals 0. Okay, this one. So 4 to the x equals 256. Anybody have any guesses? 5? Is that what I heard? So let's try. So 4 to the first is 4. 4 squared is 16. 4 cubed is 64. So 4 to the fourth is, see if I had 4 64s? That'd be the 256. So it's x equals 4. Okay, so special properties of logarithms. Okay, so I have my logarithmic form, I have my exponential form. So what is b to the first equals b? What is that in logarithmic form? Log base b, the other side's equal to 1, so log base b of b equals 1. Do you guys see? B to the 1 equals b. Okay, so basically when you see like log base 5 of 5 next to each other, or log base 2 of 2, it's just equal to 1. Okay, so how about this next one? This is in log form, write it in exponential form. B to the 0 equals 1, right? Isn't that a true statement? B to the 0 is going to be 1. That's why if you see log base b of 1 equals 0, so if I see like log base 523, we'll make a weird number, of 1, don't freak out, it's just 0, because it's something to the 0 equals 1. What was that? Yeah, this to the 0 equals 1. Makes sense. All right, so logarithmic function. This is a function of the form y equals log base b of x. Okay, it's an inverse of the function y equals b to the x. Remember how we found inverses? We switched our x and y and then solved for the new thing. So inverse, switch x and y and solve. Okay, that's why when you look at this, it's like, but wait, it should be b to the y equals x, right? But we switched our x and y, so that's why they're inverses. Okay, do you guys remember what an exponential function looks like? So let's say b was greater than 1. So let's say we had 2 to the x. 2 to the x went up, so it went like this. Okay, so this right here is like y equals b to the x. Inverses are reflected across the line y equals x. So if I'm trying to graph f of x equals log base b of x, I'm just going to take my b to the x and reflect it over the line. So instead of having this point 0, 1, what point am I going to have? 1, 0, right. And these are going to be reflected across. It's going to look like that. And then see how all these y values were greater than 0? They went along this x-axis. These are all your x values are going to be greater than 0 then. So it's going to look like that. So this one had a horizontal asymptote. This one has a vertical asymptote. Okay, so logarithms are always going to look like that. So this is the line y, or this is the curve log base b of x. Okay, so that's what you're trying to graph right there. Okay, so exponential functions always look like the top one. The logarithmic functions look like the bottom one when b is greater than 1. All right, let me see where I'm at with time.